Kakha gaga yan cha 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 na A B C D E F G H. Hey, what is this? Are we going to learn about these letters? No, not at all. But the way we remember the sequence of these letters, same way we have to remember elements in periodic table. Hello friends, welcome back to my channel Kitty Cam. In this video, we will learn about periodic classification of the elements. So this is the periodic table. And the topics which we are going to cover are the valency, atomic size, metal and non-metal properties, ionization energy and electron affinity. Let's begin with valency. The valence or the valency of an element is the measure of its combining capacity with the other atoms when it forms the chemical compounds or molecules. As we know that an element have the outermost shell, inner shell and the nucleus. In the outermost shell, the number of electrons are present that can be calculated as the valency of a particular element. So, if the element have 3 electrons in the outermost shell, the valency of the element will become 3. No, it's not like that, because you know that every other element has to have that octet or noble gas configuration. The noble gas configuration is having 8 electrons in the outermost shell. But if I have 7 electrons in the outermost shell, will it be possible for me to give 7 electrons altogether? No, it is very difficult. But I can easily have 1 electron. So gaining that 1 electron will make the valency of that particular element. So for that, we have a formula for this. A non-metallic element's valency can be calculated as 8 minus number of electrons in its outermost shell. So if I take an example of electronic configuration of magnesium is 12. So the electronic configuration is 282. That means 2 electrons in the outermost shell. They have 2 electrons in the outermost shell, so the valency of magnesium will become as 2. So in second example, nitrogen, the atomic number is 7. So the electronic configuration will be 2, 5. So 5 electrons in the outermost shell. But it is very difficult to give 5 electrons, as we can see that it is a non-metallic element. So to find out the valency of nitrogen, we can do 8 minus 5 is equals to 3. So this is the valency table. As we know, the first group have +1, second have +2. Same as third group will be having +3. Fourth group will have -4 or +4. And fifth group will have -3, 6, -2, 7th -1 and 8th group will have 0 because it is a noble gas configuration, or these are all noble gases: helium, neon, argon, krypton, xenon, radon. If we talk about what is valence electron, the outermost shell में जो electrons हैं, the electrons present in the outermost shell. As we can see the examples of magnesium in this, it has 2 electrons. So that will become the valency of magnesium. Valence electrons are important because they provide detailed information of an element's chemical characteristics, such as whether it is electronegative or electropositive in nature. So this is valence electrons in each group. Now we talk about the atomic size. So atomic size is the distance between the center of the nucleus of an atom and its outermost shell. So as we add on the electrons, the number of shells or number of orbits will increase. And as the number of orbits will increase, the atomic size will increase. So you can see in the middle, the yellow color is the nucleus. From the center of the nucleus, we will calculate the radius of the outermost shell. That will be the atomic radius. Atomic size went down the group. So, if I talk about top to bottom or down the group, the number of electronic shells will increase. Valence shells held less strongly to the nucleus with addition of repulsion of electrons in the electronic shells. We know that nucleus have positive charge at it has a protons and electrons have negative charge. So the nucleus and electrons are held together with the attraction forces between them. When we take electron far from the nucleus, this attraction force will decrease. Or we can say, as we add more electrons, more orbitals will be required. So this attraction force will decrease. Else, we can say that when there are too many electrons, the electrons itself will have a repulsion force, because negative will repel. The other point is that atomic radius will increase. As we know, when we add on the electrons, the number of orbitals will increase. So the atomic radius also increases and size of the atom will also increase. So in this, when we go down the group, the size of atom will increase. So this is atomic size trend across the period. Okay, so if we go left to right, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. So the size of the atom will decrease. So this is the periodic elements and these are the atomic radius given. Next is the metallic properties. Metallic character is the name given to the set of the chemical properties associated with the elements that are called metals. For metals and non-metal properties, you can go and watch my video which is given already in the channel. These chemical properties result from how readily the metals lose their electrons to form the cations. Now we know then when any metal loses electrons, it will become an ion. Ions are of two types, cations and anions. Cations are the positively charged ions. It forms when a metal loses electron. And anion is a negatively charged ion. It forms when a metal gains electrons. As we know that electrons have negative charge. So when the electrons are added to something, it will give more negative charge to it. That's why it will become a negatively charged ion which is called as anion. So metallic character decreases as you move across the period in the periodic table from left to right. This occurs as the atoms more readily accept electrons to fill a valence shell, then lose them to remove the unfilled shell. Metallic character increases as you move down an element group in the periodic table. This is because electrons become easier to lose as the atomic radius increases, where there is less attraction between the nucleus and the valence electron because of the increased distance between them. Non-metallic properties, the elements which have a tendency to gain electrons are known as non-metals. So the tendency to gain electrons means they will be having more negative charge on it. Moving across a period due to an increase in the nuclear charge and decrease in the atomic size. Hence, the non-metallic character increases across the period. Left to right jab hum jaate hain, then non-metallic property will increase. As we move down the group, the non-metallic character decreases due to the increase in the atomic size. As I have told you, when we move down the group, the atomic size or the atomic radius will increase. Okay, so the non-metallic character will decrease and left to right it will increase. So the trend of metallic and non-metallic properties have been shown in this, increasing the metallic character or decreasing the metallic character from left to right and from top to bottom. The next is ionization energy. Ionization energy is the quantity of energy that an isolated or gaseous atom in the ground electronic state must absorb to discharge an electron, resulting in a cation. Simple shabdon mein, if I say, in a simple words, if I say, it is the energy required to lose electron. Simply, to become a cation or an ion? No. It is only for losing electron, not to gain electron. So once the element loses the electron, it will become a cation. So the energy, the amount of energy which is required for an element to lose that particular electron, that will become the ionization energy. So ionization energy increases when we move left to right. Okay? Because the atomic radius is decreasing, moving across a period. So there is a greater effective attraction between the negatively charged electrons and the nucleus, and thus more energy is needed to remove an electron. Why? The amount of ionization energy will increase from left to right in the period because we know that there is no atomic size. The atomic size is very small. When the atomic size is small, the positively charged nucleus and the electrons will have more attraction forces between them. When they are very much binded, when they are very strongly held with each other, so we need more and more energy to break that bond. And that's why the ionization energy, the amount of ionization energy will increase to break that bond. So we can conclude that from moving left to right, the ionization energy will increase. But down top to bottom, or say moving down the group, it will decrease. Why? Because we know the atomic size, the atomic radius is increasing down the group. When the radius is increased, the electrons are not held strongly with the positively charged nucleus. And they are very far, though there is a very less bond between them. Just the way you have a best friend and a normal friend. So with the best friend, it is very difficult to break the bond. But with a normal friend, it is like quite easy. Similarly is happening when we are moving down the group. The electrons are far. When the electrons are far, we need lesser energy to break the bond. That's why the ionization energy decreases when we go down the group. So let's talk about the electron affinity. So electron affinity in chemistry, the amount of energy liberated when an electron is added to the neutral atom from a negatively charged ion. Now this is the amount of energy which is required to add the electrons. Okay, so the general trends of this electron affinity are that it increases from left to right across the period due to an increase in the nuclear charge. Because we know when we move left to right, there is too much of attraction force, no, between the nucleus and the electrons. So the electron affinity will also increase. That means the amount of energy to add another electron will be more. Similarly, in the case of moving down the group, the electrons are held apart to the nucleus. They are very far. There is no attraction forces between them, the nucleus and the electrons. So if I need to add the electron, I need very less energy to add the electrons. That's why the electron affinity will decrease top to bottom. Okay, due to the effect of the atomic size. Now this is the common trend which is given. The atomic radius down the group, ionization energy, electron affinity left to right will increase. Non-metallic character will increase. Metallic character, how they are increasing from moving where to where is showed in this diagram. Thank you for watching this video.